Simple LC circuit. Components. Voltage source, a step voltage source with a value of 10 V. Inductor, L, inductor with a value of 100 mH. Capacitor, C, capacitor with a value of 100 mF. Resistor, R, resistor with a value of 10 ohms. Circuit configuration, the inductor, L, and capacitor, C, are connected in series, creating an LC circuit. A resistor, R, is connected across the capacitor. The step voltage source is applied to the series combination of the inductor and capacitor. The output voltage is taken across the resistor. Circuit behavior. 1. Initial conditions. Initially, when the step voltage is applied, the inductor resists the sudden change in current, and the capacitor begins to charge. 2. Charging phase. During the charging phase, the voltage across the capacitor increases, and the current through the inductor gradually rises. 3. Steady state. Over time, the system reaches a steady state where the capacitor is fully charged, and the inductor current stabilizes. 4. Output voltage. The output voltage is taken across the resistor connected across the capacitor. It reflects the charging and discharging behavior of the capacitor. Time constants. Inductor, L. The inductor introduces a time constant, related to the rate of change of current. Capacitor, C. The capacitor introduces a time constant, related to the rate of change of voltage. Summary. The circuit undergoes transient behavior during the charging phase, followed by steady-state conditions. The values of the inductor, capacitor, and resistor influence the time constants and overall response of the circuit. Circuit behavior. Capacitor voltage reaches source voltage. As the capacitor charges, there comes a point where its voltage equals the voltage of the step source, 10 V. At this moment, the capacitor is fully charged. Current flow stops. When the capacitor voltage matches the source voltage, the potential difference across the circuit elements decreases, causing the current flow to stop. Steady state continues. The circuit then settles into a steady state where the capacitor is charged to the source voltage, and there is no further current flow. Output voltage stability. The output voltage across the resistor remains constant once the capacitor is fully charged, and the circuit reaches a stable condition. Implications. The capacitor acts like a temporary storage unit, absorbing energy until it reaches the source voltage. Once the capacitor is fully charged, the circuit behaves as if the capacitor is replaced by a short circuit, and no current flows through the resistor. This behavior reflects the fundamental principles of capacitive charging in an RC circuit. It's fascinating how the capacitor interacts with the rest of the circuit elements to create a dynamic response and then settles into a stable state.